All right, so for problem number 49, we're given the function y equals e to the x. And we're asked to find the tangent line of the function that passes through the origin. And so you might say to yourself, huh? And the reason for that is normally e to the x kind of has this sort of behavior, and it has a y-intercept of, let me write this down before I get ahead of myself, e to the x. The y-intercept for e to the x is actually at 1 because e to the 0 is equal to 1. And so what they're really asking us is to find or write the tangent line of the curve that passes through the origin. So it's not, this is a very unique problem in the sense that we're finding a tangent line that passes through a point that we don't know, but we know where the tangent line passes through. So the tangent line passes through 0, 0. However, e to the x does not. And so that might cause some confusion for you guys. But the process is still the same. So in order to find the tangent line, we need to find the rate of change of e to the x. And that process calls us to find the derivative. And so the derivative of e to the x is, well, it's just e to the x times the derivative of x, which is just 1. So it's just e to the x. So then the next step in that process to write the tangent line, in other words, this is the slope of the tangent line, is e to the x. Sort of. We've got to evaluate it. So now to evaluate it, or to find the tangent line, we need a point, which is weird. We need a point on the tangent line that's also on the curve. And so I need to plug in this xy value. I don't know what it is, so I'm going to call it a. But what I do know is that the corresponding y value for that is e to the a, because basically y is equal to e to the x, whatever x is. And in this particular case, I don't know what x is, so I'm going to call it a. So y is equal to e to the a. So that's the point of the curve where the tangent line crosses through the origin. And it's arbitrary because I don't know the values of a. And if I did, I would just plug that into e to the a, and that would give me my xy coordinate of the curve of the tangent line that would go through the origin. So this is a little more complicated than we're used to. So normally in this process of finding the tangent line, we would say that the slope of the tangent line is equal to e to the x evaluated at this x value. But the x value we don't know, so we're gonna evaluate it at a and just leave it like that. So the slope of the tangent line is going to be e to the a, and so we want a number. And I do know that e to the a, or e is Euler's number, which is approximately 2.72, like pi. It's an irrational number, but I guess I got to figure out what a is. And so in order to figure out what a is, we're just gonna plug this in, and then maybe there'll be some clue or something that we can use to go back and find what's going on with regards to a. Okay, so I'm gonna draw this in green so we don't get confused. I know that the slope of this is e to the a, and I know it's going to pass through the point. Now here's where it gets a little tricky. I'm gonna let it pass through the point e to the a. Now it also passes through the point 0, 0. But I'm trying to solve for a, so I think if I plug in some a's, I might be able to use some sort of system of equations to solve for a, which is what I'm going to desperately need to do. So it passes through the point a, comma, e to the a, or e evaluated at a. So now remember that we use the point slope form, which is y equals m times the quantity x minus x sub 1 plus y sub 1, where this is x sub 1 and this is y sub 1. So we get y is equal to e to the a times the quantity x minus a plus e to the a. All right, so if I distribute that through, I get e to the a times x minus a times e to the a plus e to the a. Whoops, wrote that wrong. E to the a. So now at this point, remember that the slope of remember that the tangent line is a line, so it should look like mx plus b. Well, this is my m, that's my slope, and all of this stuff here is b. So we really are going to need, in order to solve the variable a, we need a second equation which states b is equal to negative a times e to the a plus e to the a. Now, remembering also that b is equal to the y-intercept. And we said this thing crosses through the origin, so the y-intercept is 0. So I can plug in the 0 for b and say minus a e to the a plus e to the a. Move this over to the other side, and I get a times e to the a is equal to e to the a. Now, we could use natural log and stuff to solve for this, but I can almost guess that a has to equal 1, because that would give me 1 is equal to e to the 1, which is also equal to e to the 1. And so that value works. Okay? And so if that's the case, if a equals 1, then what I can do, since I already know what my y-intercept is, I could say that y is equal to e to the 1 times x plus 0